about 1 minute. If you're working on a problem, see if you can kind of finish it up real fast. We'll talk, and then we'll get our homework. How'd you do, Charlie?
Okay, so you should after that you should get.
Did we figure out one yet?
I did.
What'd you do, Kristen?
I had a natural log of -2 to the x plus 20 to the x first.
Oh, and then
Like I had function 0. So I said either the 0 equals the fraction. And then I multiplied the denominator.
okay, yeah, that works. There is probably an easier way. You're using properties of exponents. She subtracted it over and then you condensed it from yesterday, right? So she condensed it into a single log and then she just rewrote it.
Okay, so what's
But I'm going to talk about this on the board here in just a minute. But if you're taking the natural log of something and it's equal to the natural log of something else, what must be true about something else? It must be true. So you know that the two things are.
Okay.
But Kristen's algebra will confirm that that's the same answer.
Well, she got
So
the
we're
right
just kind of like thinking about number sense wise, but you're actually doing it. Okay, I'm going to interrupt. Now, you can keep this yellow sheet. Maybe you'll want to attach it into your notebook. The tips over here on the side might be good for you to read over. But I want you to remember this. You have all the tools you needed to solve these equations. It is a little bit funny when you get to the logs or the exponents, but it's just like solving equations from other chapters. So I want to first talk about 1 and 2. Okay. These are equations where you have like logs on both sides, or you have base raised to exponent on both sides. And really important is that they have the same bases. Like natural logs are both base E, and then in the second one I have base 3 for both of them. So there's some different ways to approach these problems, but I think just approaching with number sense wise is probably easiest. If you have the natural log of something, and it is equal to the natural log of something else, what must be true?
They're equal.
The things must be equal behind the natural logs. Like if you type natural log of 20 into your calculator, you'll get a decimal. The only thing that will equal that same decimal is the natural log of 20, right? So 6x minus 4 must be equal to negative 2x plus 20. Okay, and that must be the case. And if you solve that, that's x equals 3. Okay, so as I walked around, most people had x equals 3. Now, there are some more algebraic approaches you can take. I saw a lot of good stuff going around. Kristen moved one of the natural logs to the other side and then condensed from yesterday. And then she had to rewrite and solve. Logan rewrote one of them as e to the natural log of the thing on the other side because that's the exponent, and then it equals this thing behind it. Well, then you use your inverse property and that cancels out. Either way, everybody's coming up with basically this line somewhere in their work. And the same could be true for number 2, right? 3 to the something only equals 3 to the something else if the two somethings are equal. So 4x minus 4 equals x plus 8. And that one comes out to be x equals 4 when you solve it. Okay. Now, I want to talk just really quickly about numbers 3 and 4. Note to yourself, you are in Algebra 2. So you know that in number 3, dividing by 4 is not an option. If it was divide by 4, it would look like 4 times x plus 1. So I can't divide by 4. Okay. I want to talk about step 2 on the tips. It says, given an exponential equation, it's the second one. Given an exponential equation, take the log of each side to remove the base. be sure to match the base of the log to the base of the exponent. So if you want to treat it like, algebra and we got to balance both sides, we can still do that. Since this exponent has base 4, I can take the log base 4 of both sides. So this is the log base 4 of 4 to the x plus 1, and that's okay as long as on the other side I do log base 4 of 40. Well, what happens on the left? Log base 4 of 4 to the x plus 1. It's just x plus 1. That's our inverse property. X plus 1 equals log base 4 of 40. Can you evaluate that? Change your base. Log of 40 divided by log of 4. And finally, to solve, subtract 1 from both sides. And I think we get something like, is it 1.661? Awesome. Now, maybe not all groups did the logs of both sides. Another approach to that is like in number 2, it says rewrite the equation in logarithmic form. So if you're comfortable just changing it into log form, that's all you got to do. On number 4, I might use that first tip in number 2. Just rewrite it in exponential form. So what's the base to the exponent? 2. What's the exponent? 5, because the answer to a log is an exponent, equals 5x plus 7. Can you solve it? Yeah, that's just 32 equals 5x plus 7. And what did we get on that one? 5? Equals 5. Now, on the last two, you're kind of doing the same thing as you are for 3 and 4, but they've got extra numbers there. So just remember, it's your job to move those things to the other side first. So essentially you want to isolate a log or isolate a base to an exponent. So I would subtract 1. You cannot multiply 2 and 3 because this 3 has an exponent, and in PEMDAS you have to do that first. So rather than multiply those two numbers, get rid of 2 by dividing. Now rewrite as a log or take the log base 3 of both sides. Okay, so this would be log base 3 of 21 equals x minus 3. Change your base, add 3. On this one, add 4. Divide by 3. It's in a log. Rewrite it as an exponent. 2 to the third equals x minus 1. Okay. For these last two, I'm using our definition of a log. The log base b of y equals x if and only if b to the x equals y. So I'm just rearranging it in whichever form I need it to be in so I can solve. Okay? It's not so bad, is it? It will maybe be a little bit scary on Tuesday after we've had a 4-day break. Can you imagine?
What were your answers for 5?
For 5, I got x equals 5.771, and 6 is x equals 9. 9.
Oh, wait, 9. And what did you 7 and 8?
Hang on. 7 and 8, we're going to talk about those on Tuesday. I'll do like regular notes. They involve the properties of logs. So I can tell you what the answers are here.
I subtracted this
Miss Cronky, can I have a bathroom?
Number 7 is x equals 2, and in number 8, x equals 1.
I was right. Darn it.
Alright.
Okay, now I'm going to get you going on this. We got about 5 minutes. It's not going to take us long to do a couple problems. Let's start with number 1. E to the x equals 9. One approach to this is to take the log of both sides. If your exponent has base e, what log would you use? Natural log. I could do natural log of e to the x equals natural log of 9. As long as I do it to both sides of my equation, I'm good. What happens to natural log of e to the x? cancels. It's just x equals natural log 9. You can type that in your calculator. Easy. Natural log 9. Let's see. 2.197? Got an answer. If you want to check the reasonableness of your answer, would e to the 2.197 equal 9? Yeah, I mean, think about e is like almost 3, and then if you almost square it, be close to 9. Yeah. Number 2, looks like 2 to the x plus 1 equals 5. If I want to get rid of base 2 on an exponent, take the log base 2 of both sides. After a while, maybe you don't have to keep writing that log on that side because you know what's going to happen. It's going to cancel out. It's going to be x plus 1 equals. Can you do log base 2 of 5?
Yes, they're change of base.
Change of base formula. Log 5 divided by log 2. And whatever I get, I'm going to subtract 1 from it. So, what do we get? 1.322? Number 3. Log base 5 of x equals -1. What are you going to do?
Exponential.
Write it in exponential form. What's the base?
5.
What's the exponent?
-1.
Just equals x, right?
Yep.
So we could say x equals 1/5. I don't even need to type that in my calculator. If you say 0.2, that's the same thing. Tell me what's 4. Natural log of 4x equals 2. 2. How are you going to solve? The base is e, right? If you don't see that base for natural log, you know it's e. So we can say e
Squared.
to the 2 squared equals 4x. And then you just have to do e squared divided by 4 in your calculator. It's really not so bad. I got 1.847. Okay? So, there's a backside. Yes. There's what, 18 problems, but we've done 4 of them.
You can keep going.
So
No, I'm good. Thank you, though.